All right, so we learned that there are seven different classes of minerals, but silicates are by far the most common on Earth. And there are 7 common rock-forming minerals, right? Meaning that of all of the minerals on Earth, of all the minerals everywhere, and there are hundreds, not thousands, really, in this class, you only need to know about 7 of them. And these are the most common rock-forming minerals. So next week, as we get into rocks, these are the minerals that are going to pop up over and over and over again. The first one is quartz. We are going to see quartz everywhere. Quartz is incredibly common. The next is olivine, a beautiful olive green color. Pyroxenes, feldspars, amphiboles, biotite mica, calcite. And by the way, calcite is the only non-silicate on this list. All of those other ones, all of the other 6 common rock-forming minerals are all silicates. Calcite's the only non-silicate. All right, the last thing we're going to talk about this time is one more way we classify minerals. And I think that this classification is going to be the most important for us. And that is classifying minerals based on how much silica they have in them. Remember, I said silicates are one of the most, or it is the most common type of mineral on Earth, right? So classifying minerals based on how much silica they have in them is a really good way for us to talk about minerals and talk about how they're going to behave. So felsic minerals, those are the ones that are really, really rich in silica. They've got a lot of silica in them. They also have a lot of aluminum. In contrast, they're really poor in iron and magnesium. And silica, right, it produces light colored or light shaded minerals. So white quartz, light colored mica, light pink orthoclase, those are all felsic minerals. Mafic minerals, on the other hand, those are the ones that don't have much silica within them. Instead, they're rich in iron and magnesium. And because of that, they're denser, right? They have these, the larger, heavier elements, they're denser. And because they lack silica, they're often darker in color, these dark grays, blacks, dark greens. Examples of this would be the biotite mica, amphiboles, olivines. All right, so keep this in mind, because next week when we start talking about rocks and magma and volcanoes, a lot of it is going to come back to how much silica is there in these minerals, and that's going to change how a lot of these processes work.